Hello everyone, welcome to my channel, and today I am excited to share my post system project with you. This is a full stack web application that I developed using Spring Boot for the backend, MySQL for database management, and HTML, CSS and JavaScript for the frontend. In this video, I will walk you through the system architecture, layered backend design, database integration, API communication, and the core features of the project. Let's explore how the system is built and how all the components work together. This post system is mainly designed to manage customers, manage items, and handle order processing in a simple and efficient way. First, I will explain the overall structure of my system. My system has two main parts, the front-end part and the back-end part. This is the front-end part. This is a back-end part. The front-end part include page like index.html, customer.html, item.html, and placeholder.html. It also included CSS and JavaScript files. The frontend is responsible for displaying the user interface, getting user input, and sending data to the backend using API calls. Now let us move to the backend part. The backend part is developed using Spring Boot. The backend handles business logic, database communication, data validation, and API response. Now I will explain the backend structure. My backend follows a layered architecture. This means each layer has separate responsibilities. First, let's look at the entity layer. The entity class like customer, item, order represent database tables. These classes are mapped to the database using JPA annotations like entity annotation and ID annotation. This is entity annotation. This is ID annotation. Next, let's move to the repository layer. Repositories extend JPA repositories. This helps to perform database operations like saving, updating, deleting, and retrieving data. The good thing is the Spring Boot automatically generates the SQL queries, so we don't need to write them manually. Now let us move to the DTO layer. DTO means data transfer object. DTO classes like customer DTO, item DTO, and order DTO are used to transfer data between frontend and backend. This helps to protect entity data and control what information is sent to the client. After that, let's go to the service layer. This layer contains the business logic. The controllers does not directly communication with the repository. Instead, it communicates with the service layer. The service layer performs validations, processes data, and then calls the repository. This is example for validations. Now let us move to the control layer. Controllers handle HTTP requests like get, post, put, and delete. When the frontend sends a request, the controller received it, calls the service layer, and then sends the response back to the frontend. The main HTTP method annotations in Spring Boot. We use special annotations to handle different type of HTTP requests in REST APIs. Post mapping. This is used to save or create new data in the database. Example, when we added a new customer, we used post mapping. Then get mapping. This is used to review data from the server. Example, when we want to get all customer, we use get mapping annotation. Then put mapping annotation. This is used to update existing data. Example, if we want to update customer details, we use put mapping annotation. Then delete mapping annotation. This is used to delete data. Example, when removing a customer by ID, we use delete mapping annotation for it. These annotations help us build RESTful APIs easily and clearly in Spring Boot. That's quick introduction to post, get, put, and delete annotations. I have also implemented global exception handling to manage errors properly. This helps to catch errors and send meaningful error messages instead of crashing the system. Additionally, I create an API response wrapper class. This is used to send structured response including status, messages, and data. So all API responses are clean and consistent. Since my frontend and backend run separately, I configure cross to allow communication between them. Now I will explain the frontend part. First, let's go to the main page. This is index.html. It acts as the navigation page. From here, users can go to customer management, item management, and order management. Order management can have place order option. Now let's move to the customer page. In this page, user can add, update, delete and view customers. When I click the save button, the JavaScript file sends a post request to the backend. If I click update, it sends a put request. The table below displays all customers by calling a get API. Now we will see how customer page work. First, we can add customer ID here. Then we can add customer name. Then customer address. Then click add new customer and we can message customer saved. Then we can display our new saved customer in the table. Now let's move to the item page. This is item page UI view. Here we can manage items. Let's try adding a new item. I enter item code, name, price and quantity, then click save. This sends a request to the backend and stores the item in the database. If I select an existing item and click update, it updates the database record. If I click delete, it removes the item. Now we can see how item page work. We can give item ID here, then item name, then we can select quantity, then we can choose unit price, then press add item button, then newly added item saved message display in our UI. Then we can see our newly added item in stock overview table. Then I want to update it, quantity 30 down into 20, click update button and item updated successful message display in our UI. Then we can display it our table. Now let's look at the JavaScript code for this page in item script page. We use the fetch function to send API requests to the backend endpoints. For example, fetch is used to call get to load items and post to save item. Now let's move to the place order page, which is the main feature of this system. This is the place order UI. Here I first select a customer. Then I select item and added them to the cart. When I add items, the system automatically calculates the total amount. Now let's place an order. When I click the place order button, the order details include order ID, customer ID, date, item list and total amount are sent to the backend. The backend saves the order and related order items in the database. Now let me explain the full system flow. When the user enters data in the frontend, JavaScript sends an API request. The controller received it, calls the service layer, the service processes it, and the repository saves it in the MySQL database. Then the response comes back to the frontend and updates the UI. For the database connection, I configure it inside application properties. It includes the database URL, username, password and JPA settings. So, overall, the system includes customer management, item management, and order management. It follows REST API principles and layered architecture. In conclusion, this POS system is building using Spring Boot, MySQL, HTML, CSS, and JavaScript. It is scalable, maintainable, and follows proper software architecture principles. Now I will explain the complete system flow. User enters the data in frontend, then JavaScript sends API request. Controller receives request, then service process business logics. Then repository saves data in MySQL. Then response is sent back. Then UI updates automatically. This makes the system fully functional. Key features of my POS system: full CRUD operations, layered architecture, REST API design, database integration, dynamic order processing, clean UI design. In conclusion, this POS system is a full-stack web application building using Spring Boot, MySQL, HTML, CSS, and JavaScript. It follows proper software architecture and REST API standards. Alright guys, that's it for today's video. I hope you found this video helpful and learned something valuable. If you did, don't forget to like this video and share it with your friends. If you are new to the channel, make sure to hit that subscribe button and turn on the notification bell so you never miss my upcoming videos. If you have any questions or suggestions, drop them in the comment section below. I'd love to hear from you. And remember, if something didn't work in your code or project, don't worry. Even computers need a restart sometimes. Thank you so much for watching, and I'll see you in the next video. Until then, stay safe and keep learning.